When I'm solving a system of equations, I can use elimination, substitution, or graphing. But when I start solving a system of inequalities, I have to approach it using graphing. So I look at my system of inequalities, and in order to graph them, I want to put them in slope-intercept. When I look at the first one, I'm okay with it because it's already in slope-intercept. But when I look at the second, there's some work that has to be done. So I take my second inequality, and I begin to solve for y. So I subtract the 4x over. And in doing so, I get 6 minus 4x on the right-hand side. And then divide everybody by 3. So I get y is less than or equal to 2 minus 4/3 x, which is now in slope-intercept. So I can easily graph it. The one thing I have to be careful of when I'm graphing inequalities is if y is strictly greater than or strictly less than, I have to use a dashed line. So for the first inequality, I begin at 2, and then go up 3 over 1, or down 3, left 1. And I have to put a dashed line through those points. For the second inequality, I notice that y is less than or equal to. So that's going to be solid. So I graph that by starting at 2 and going down 4 and over 3, or up 4 and left 3, and putting a solid line down through those. Remember, if you ever miss your dot, just make it bigger. Since these are inequalities, I have to consider the shading. That's what differentiates inequalities from equations. For the first one, I have y is strictly greater than. So I come over and realize that means to shade above the purple line and above the purple line. I like to put little reminder arrows on my line so I know where I'm shading. For the second one, the blue one, it's y is less than or equal to, so I'm shading below the blue line and below the blue line. I put little reminder arrows. And then I look to see which of my regions on my coordinate plane has all of the arrows pointing to it, because that is my solution region. In this case, it's the far left-hand region. Those are the solutions to my system of inequalities. I have an infinite number of solutions comprised of a region on the coordinate plane. Anything in any other region is not a solution. For our second example, we're going to kick it up a notch, and we're going to go with a system of 3 inequalities, put them all on the coordinate plane, and find out what the solution looks like. When I go to graph these, the first one, I have to be very careful because there's a negative coefficient on y. And traditionally, when there's a negative coefficient on y, at some point I might have to flip the direction of the sign. Remember, with inequalities, when you divide by a negative, you have to flip. So when I put this into slope-intercept, I divide everybody by -1. So I get a y on the left-hand side. Negative 2/3 x minus 4. And flip the direction of that sign. Now it's y is less than or equal to. This is now in slope-intercept, which is very easy to graph. Start at -4, and then go down 2 over 3, or up to left 3, and put a solid line through those points, because y is less than or equal to. Now when I consider the shading, because it's an inequality, I notice y is less than or equal to, so I put little reminder arrows that I will be shading below that line. And I'm done with him for now. The second one, in blue, I notice there are no x's. And if there are no x's, I have a horizontal line. Y is less than or equal to -2. So I go to -2 and give myself a solid line horizontally through -2 on the y-axis. And if y is less than or equal to, I am shading below that. So you can start to see what region might be my solution region. It's going to be somewhere down in this area, down here. But I have to take into account this final inequality. First thing I notice when I look at it is I'm going to have a dashed line because x is strictly greater than. And I also notice that I'm missing all the y's, which makes this vertical. So I have a vertical line going through -6 that is going to be dashed. So last but not least, I think, what does x is greater than mean? It means I'm to the right. So I'm going to be over here and over here. And when I start to put this all together, I notice that my solution region is this region down here where all the arrows point. Again, these are my solutions, which means that every other region in the coordinate plane is not a solution to this system of inequalities.